Load balancing is the ability to distribute incoming workloads to multiple end stations based on some kind of algorithm. Load balancers operate at different OSI layers, and the common operation is between layer 4 and layer 7. Each network hosts unique applications with different requirements. Every application is unique in respect to the number of sockets, TCP connections that are short-lived or long-lived, idle timeouts, and activities in a session in terms of packets per second. So one of the most important elements of designing a load balance solution is to understand fully the application structure and its protocols. For example, real-time streaming protocol. The initial client connects with TCP. However, return traffic from the server can be UDP, bypassing the load balancer. For this scenario, load balancing method of direct server return is a viable option. The load balancing function becomes the virtual representation of the application. Internal applications are represented by what's known as the virtual IP address, a VIP. The VIP acts as the front end serving external clients' requests. The major benefit of load balancing is that it provides scalability. Scalability is the ability of a network device or application to handle organic or planned network growth. Scalability is the main advantage of load balancing, and in terms of application capacity, it increases the number of supported concurrent requests. Expand linear by buying bigger servers, adding additional CPU and memory. Scale up is usually done on transaction database servers, as these types of servers are difficult to scale out. Scaling up is a simpler approach, but it's the most expensive and it's also non-linear. Old applications were upgraded by scaling up, i.e. vertical scaling. It's a rigid approach which is not elastic. In a virtualized environment, applications are now scaled linearly in a scale-out fashion. This is done by adding more parallel servers, i.e. we are now scaling linearly. Scaling out is easier to be done on web servers. You just simply add web servers as needed. Netflix is a perfect example of a company that scales by design. It spins up different VMs on demand due to daily changes on network load. Scaling out is elastic and it requires a load balancing component. The scalability of scale-out architectures is limited by shared state, so try to share and lock as little state as possible. An example of a server locking is a eventual consistency approach used by Amazon, where they limit the amount of transaction logging. Shopping carts are not checked until you buy. So on the outside there is a VIP, and on the inside a pool of servers exist. A load balancer device is configured for rules associated with the outside IP address and port numbers to the inside pool of servers. Clients only know the outside IP address through DNS replies. The load balancing control plane monitors the health of the servers and determines which ones are able to accept requests. For example, a client sends a TCP SYN packet which gets intercepted by the load balancer device. The load balancer carries out an algorithm and sends to the best server destination. To get the request to the server, you can either use tunneling, NAT, or 2 TCP sessions. In some cases, the load balancer will have to rewrite the content. Whatever the case may be, the load balancer has to create a session so it knows that this client is associated with a particular inside server. Local server selection takes place within the network and is based on criteria such as server load and application response times. Any application that uses TCP or UDP protocols can be load balanced, whereas local load balancer determines the best device within a network. Global load balancer chooses the best entry network location to service a client request. Global load balancer is supported through redirection based on DNS and HTTP. HTTP mechanisms provide better control, while DNS is fast and scalable. Both local and global appliances work hand in hand. The local device feeds information to the global device, enabling it to make better load balancing decisions.